So you should have yesterday seen like there's multiple ways to represent a line, right? And this sheet, it's not as organized as the sheet I gave you yesterday in terms of the way it's broken down. Okay, in the 4 different quadrants, but everything's still here, right? You've got kind of some words depicting what's going on, right? Kind of whatever. They were nice in this particular question because they gave you the equations, right? That was also one of our boxes yesterday. We had the table of values yesterday in the multiple representations, and then we had the graph. Okay, there's your 4 representations. And those are really like the 4 ways that you can actually represent a scenario, I suppose. You got words, you got equations, you got tables of values, and you have graphs. All of them are useful in different situations. Okay, it doesn't matter if the graph we're drawing is a line or if we're making a more complicated graph. The equations can be useful for different information, and that's what we're just going to spend our time doing in this course, right? Is looking at the benefits of a table of values, the benefits of using a graph, the benefits of using the equation, and then how to manipulate equations to give us different information. Okay, that's it. That's what we're going to spend our time doing. Okay, and so here's what we got. This is like a typical. This is a little bit dated because cell phones operate differently now, right? But in the past, when cell phones first came out, you always had like a flat rate that you were going to pay for the phone, right? So for this particular question, you're going to have $20 that you would pay for the flat rate for the phone, and then you'd pay 50 cents a minute to talk on the phone or something like that, right? That's what it's kind of depicting. Okay. And then the opposite is true here. We've got $25 flat rate per month, and then 25 cents per minute. I think to relate it to you guys a little bit more, like when cell phones first came out, they didn't have data, right? But I think now you could relate this as like being, I don't know, and this is really cheap, but you could be like 50 cents for every gig of data you use, or 50 cents for every additional gig of data you use outside of your plan, right? On top of that, you're going to pay $20 a month. That'll be a really cheap phone, but you guys get what I'm saying, right? You've got a flat rate or a starting value, and then you have how something's changing if you do something else, right? If you use more data, if you talk on the phone, sort of thing. That's what's going on here, right? And ultimately, what we want to know, because you guys, the consumers, right, for anything, whether it's cell phones, whether it's somebody coming into your house to do work on a bathroom or like build a fence or something, right? You want to figure out, you want to get multiple quotes, and then you want to make a decision as to which quote you should choose when. That is the foundation of what we're going to do for probably the next 2 days minimum, maybe even into Monday. Okay, so you're concentrating on this, what we called yesterday in that second video or the afternoon lesson, this point of intersection, right? Where the 2 lines cross. That's what we're going to spend all of our time doing in the next little bit. It could be 3-4 days actually. Okay. Very, very important. All the skills I've tried to teach you from the beginning till now are going to come into play. Okay. So, with that being said, I'm going to provide a little bit more context here around a word problem. Okay, and the word problems are nice because they give you that context, right? Yesterday you just had 2 graphs on a piece of paper, and well, here's where they cross. Doesn't mean anything, right? The word problems are nice because we provide context, and we can actually make sense of what's actually going on. Okay, and that's what we're going to find out today. So, without further ado, let's have a look at, and I'm going to do these graphs in different colors, okay? Like, so for the call a lot plan, I'm going to do it in blue, and I'll do the talk more plan in red, okay? So we can just visually see the difference, okay? So you have to ask yourself, and I've already kind of said this a little bit. When I look at the call a lot plan, right, the blue equation, how much is it going to cost me to talk on the phone for 0 minutes is going to be your question, right? Well, you can use your equation, right? You could say cost is equal to, right? Because that's what it's saying. C is equal to 0.5. And then you're going to plug in, well, how long are you going to talk on the phone? Well, for this one, we're going to say 0. Well, 0.5 times 0 is going to be 0 plus 20. Well, the cost to do that, to talk on the phone for 0 minutes, is going to be $20. And so this is the cost, or the C value, that goes into the table, 20. We saw yesterday what that was called. Called this our y-intercept, or starting value, or constant. Okay, all three of those things were the same thing. They mean the same thing. Okay, does anybody have any questions? So an equation allows you to, and much like your visual patterns where there's an input and an output. So stage number is the input and the number of trees would have been the output, right? Same thing here. Time is the input, output is how much it costs. And that's what happens, right? So you could do that for all of these points, right? Where you plug in each of these time values in for t, where the 0 went, right? Or the t. You plug in time values, it's going to spit out costs, right? Or green values. Okay? And you create a table, and then you go and plot those points. Okay? So what ends up happening is we're going to basically, we can do the first couple points, and then we can see what the pattern is, much like you guys saw the pattern of how many trees were being added yesterday, or the first differences, right? The slope, right? We can see how the graph is changing in the first differences. Okay? And you can use that to fill out the rest of the table. So let's just, for instance, pretend I'm going to plug in C is equal to 0.5 times, I'm going to do 5 this time. That's going to be, oh, I forgot the plus. 0.5 times 5 plus 20, right? So you're going to go, well, half of 5 is going to be 2.5 plus 20. That's going to be 22.5, and that's what's going to go here, right? So it looks like for every 5 minutes you talk on the phone, you're going to be charged an extra $2.50. And that's your slope. Right, or 0.5. Because 2.5 divided by 5, that's 0.5. Well, where do we see that number? Right here. The slope. The rate of change, right? So you know the slope is 0.5 relative to this table because I'm increasing by 5, increasing by 5, increasing by 5, right? On the other side, I have to increase by 250 each time, right? And so to fill out this table, 2250 plus another 250 is going to be 25. And then 2750. And then $30. Sorry. 30 and 32.50 and 35. Okay, does anybody have any questions with what happened there? You could produce that entire table of values by using the equation and plugging in every single time value and producing the outputs. Okay, I don't want to do that. I don't think you want to do that either. Right? You want to use some skill and recognition of the slope to do it. Right? Recognize the pattern and use that pattern to figure out what the end product is going to be, right? So, we should know that if I add by the same amount each time, or my first differences are the same, then that should produce a linear graph, right? Should be aligned because all these numbers here match. The first differences are all the same. We get a linear graph. Okay? And so we're going to go and we're just going to plot these points, right? So we're going to say, okay, when I talk on the phone for 0 minutes, right? We got to label our axes. Sorry, let's not get carried away. So down here, this is going to be time in minutes, right? And along the y-axis, we're going to have cost, right, in dollars. And we call these, the cost depends on the time, right? So this is the dependent. And if we label the y-axis as being the dependent variable, then across the bottom, x has to be the independent. We talked about yesterday, what am I doing? I can't spell today. Independent. Okay? Here's my dog. Okay? And so across the bottom, we're going to have the independent because we talked about time continuing on forever, irregardless of what happens, right? So you have this independent variable. Okay? And so all you're going to do is you're going to go plot these points, right? And the graph that you should see will be a line for this reasoning here, right? They're all the same. Okay? So let's just plot some points, and I'll do them in blue so that you can see. Right? So we're going to go 0 and 20. Where's 20? Right there. Right, there's our first point. And then we're going to go 5. 5 is here. 5 and 22.5. Well, that's going to go right there. Right? And then 15. Oh, I skipped over 10, sorry. Gotta go 10 first. 10. 10 goes up. Right? Where am I going to stop? I'm going to stop at 25, right there. Right? This is how you plot points, right? And you go to the next one. You say, okay, 15. 15's right here. I got to go all the way up to 27.5. That looks like right here. Okay, you could keep going. I think we kind of get the idea. I can connect these now and say, here we go. Right? There's the graph that represents okay? Now we can flip over and do the exact same thing with the talk more. Right? And remember, we're going to do the talk more graph in red. Right? So you're looking, and you want to make a direct comparison too, right? So you want to say, okay, well, if I talk on the phone for 0 minutes, how much is it going to cost me? If I talk on 5, if I talk for 10, 15, 20, 25, and 30, right? You want to make these match so you can have this direct comparison, right? And then all you do is you take the equation and you just do the same thing. Well, you can look at it and say, well, if I talk on the phone for 0 minutes, then I'm going to get 0.25 times 0 plus 25. Well, that's going to be 25. So your starting value for this particular graph is going to be $25. Okay? So then let's do the next one. Right? Once we have 2 of them, I think we're okay. So let's say, okay, that's great. What about, even if you wanted to do 10, and I'm picking 10 because I know 0.25 times 10 is going to be a nice number, right? I don't necessarily need my calculator to do that one. Right? So you're going to say 0.25. I might erase some blue because we're getting a little bit crowded here. Okay, cost equals 0.25 times 10. You know what, guys? Let's do 5. I just want to keep it simple. Okay. 0.25 times 5 plus 25. 1/4 of 5, I think, is 1.25. If I'm not mistaken. Yes. But we'll check it. Make sure we're right so we don't have any silly graphs. So 5 times 0.25. That's 1.25 plus 25 is equal to 26.25. All right, how did we get from there to there? We added, I know this is getting crowded, guys, 1.25. Okay, we added. And so you're just going to continue to add 1.25 for each of these, right? Because you know it has to be a line. Okay. Just for the interest of time, we're just going to use a little bit of a shortcut to help us produce this graph. Okay. So you're going to say, okay, 26.25 plus 1.25, that's going to be 27.50, and then 28.75, and then we're going to go to 30. Is it $30? Yeah. And then we're going to go to 31.25 and 32.50. Okay. All I did was add the 1.25 every time. Okay. Then what you're going to do, you're going to say, okay, I'm going to go to my graph and I'm going to plot all these points. And something's going to happen. These two graphs are going to cross somewhere. Where that somewhere is the point of interest or the point of intersection, right? That's what we're interested in. Okay. And so let's take a look. We're going to go and we're going to plot these points. So 0 and 25, that's right. Oops, I need the red. 0 and 25 is right here. Okay, and then I'm going to go 5. 5, I have to go up to 26.25, which is about there. And then 10 and 27.5, that's going to go to there. And then 15 and 28.75, so almost at 30. Go there. And then 20 and 30. 30 is up here. I think I'm a little bit off my graph. And then 25 and 21. Or 31, sorry, 31. I think my blue graph is a little bit off. We're going to fix that. Whoa, hold on. What is going on? A little bit off. Okay, I'm going to fix the blue graph too in a minute. Okay, and then you guys connect the dots. You're going to see the two graphs cross somewhere, right? I'm going to fix the blue graph so that they cross in a better spot because I think the graph is just a tiny bit off. And this creates the issue and sets up. See how my graph wasn't perfect, right? And that's just based on where I'm estimating put the dots, right? This is one of the weaknesses of graphing. When you're looking for a very specific answer, you kind of get a little bit of funniness going on based on how you graph and where you interpret to put the points, right? And so those two graphs cross right here. Okay? What is the value of that point? Well, it looks like we're at 20. I'm a little bit off that line, but it looks like I'm at 20 and should be at 30. We're a little bit off. Okay? I know what the point of intersection is supposed to be because look at my tables. What is the cost when I'm at 20 minutes of talking? 30 for call a lot. What is the cost when I'm at 20 minutes of talking for talk more? 30. It's at this point that the two graphs are the same. And so we call this the point of intersection, right? I'll put that into... right? The point of intersection. When you have weird equations like this with the decimals, the graphs get a bit funny, right? And that's why we don't have this nice exact point of intersection here where we expect it to be, right? But you can use the table to figure it out, right? The graphs gives you an idea, you're in the ballpark there where the point of intersection is, right? But that's just one of the limitations that I was talking about at the beginning of this lesson with graphing. And it really sets up where we're going this afternoon and why. Okay? Does anybody have any comments or concerns about that graph before I go down and answer some questions? You can drop them in the chat. Okay, that's a good question, Wyatt. And that's what we're going to do this afternoon, right? This is exactly like... the graph is not great for points of intersections that are not directly on the grid lines, right? It's a limitation. And that's good that you've asked that question, because really, if it's not right bang on a grid line, you're taking a guess, right? We don't like guessing in math. Like, we want to have a way to actually get the exact answer. If it's a decimal, we want to be able to get that decimal. That's what I'm going to show you this afternoon. What I want you guys to take out of this morning session is just to kind of wrap up what we did yesterday, everything that we've done, and flip it into something and provide some context around some of the video that you watched this afternoon, or yesterday afternoon, right? About what this point of intersection is, right? It's great to be able to plot it on a graph and find it, but you guys need to be able to interpret it as well. Okay, and that's what these questions at the bottom are going to do. Okay, so I just want to contextualize for you guys. When I look at those two equations at the top, like if I'm answering number one, I'm going to look at the line you sketched for call a lot. Well, that's in blue. Okay, what is the slope and y-intercept of the line? The y-intercept is the easy one. Everybody should get the y-intercept, right? It's where it crosses the y-axis. Where does the blue line cross the y-axis? At 20. Right? So the b value is 20. Where do I see that in my equation? Right there. Okay? What is the slope, or how do we move around? Well, we move, we have a rise over run, which is 2.5 over 5, which is 0.5. Where do I see this number? Right here, in front of the variable. Okay, we can do the exact same thing for the red graph. We're going to say, okay, well, where's the red graph start? The red graph starts at 25. How does it change? Well, it looks like we go up. This is the M. We're going to rise over run. It looks like we're going up 1.25 and over 5. That turns into 0.25 when you divide it in your calculator. Where do I see this number? Right there. Up in your equation. Okay? It's those two pieces of information that allow you to create linear equations and then plot them. They're not always nice numbers. The ones we'll do on the Jamboard in about 5 minutes will be nice numbers. Okay? But the point is, in the real world, like this question, we can have decimals, and decimals are not necessarily nice, right? It makes sense for this question because we can have things like dollars and cents, right? Where it's 25 cents per minute of talking or 50 cents per minute of talking. Okay? So for the talk more graph, that's the red one. What does the ordered pair 8 and 27 mean? Well, let's go find 8 and 27. 8 and 27 is right. Where'd it go? 8 and 27. See how it's not even really right on? 8 and 27 means when, here I'll write it in red so it's all related. When you talk for 8 minutes, the cost is $27. That's what that point means, because you have T and C, cost. So for 8 minutes of talking, the cost is $27. Okay? So, Leslie, and this is kind of, there's lots of extra stuff here that you guys could probably go down after. This is all one big lesson. It's a pretty good sheet, actually, for what we're doing today. Okay, we got lots to do today, but Leslie uses 13 minutes of the Talk More plan, right? So we're still in the red plan, Talk More, right? Calculate exactly how much it will cost, right? So I like writing down the equation where cost is equal to 0.25 multiplied by T plus the 25. Well, it's going to cost 13 minutes. Minutes is time. Where's time? Right here. So you're going to go 0.25 multiplied by 13 plus 25. So all you have to do is do the math on 0.25 times 13, which I don't know off the top of my head. It's 3.25. That's going to equal 28.25. If she uses okay. Now, Derek had a bill of $29 last month, right? How many minutes did he use, right? But we're using the blue plan now because it's call a lot, right? And so again, I write out the equation. I always like just writing the equation out. 0.5 T plus 20. Oh, I'm coughing. I'm just copying. See what I mean? Plus 20. Okay. What is Derek's situation talking about? Dollars. Cost. Where does cost go in our equation? Well, it's not going to go in for T because T stands for time, right? So that means it's got to go in over here under the C. So 29 equals 0.5 T plus 20. This is a little more complicated version of what I showed you on Monday, of solving an equation for a variable, in this case T. Right? So all you have to do is collect the like terms by organizing similar things on one side and the other. Right? I see right now, I see a number and a number. And then I also see a number and a variable. Okay, or a rod. I cannot add the rod and the number together, but I can add the two purple things together. Right? To do that, you're going to have to create a zero pair. So, and then when you do that, you got to do it to the other side. So I'm going to go 29 minus 20 is equal to 0.5 T. That's 9 equals 0.5 T. How are these two things attached? With multiplication. What's the opposite of multiplying? Division. Divide both sides by 0.5. T will equal 18. Which will mean, I'm going to move this over a little bit so I got some more room to write. Derek talked for 18 minutes. Anybody have any questions? I'm going to jump back to the chat here. For some reason, I don't get notifications, so you guys put things in the chat. Okay, nothing. If you guys don't have any questions, I'm hoping that's the case, but does anybody have any questions with what happened there? Okay, I'm not quite done this sheet. There's like one question left, and this is kind of the meat and potatoes of this lesson and what I'm trying to do here. Okay. Now, this, if you get this, you can put that on top of what we did yesterday, right? And it will make sense. Under what conditions would talk more be a better deal or better plan than call a lot? You are talking about, when it asks you a question like this, you are talking about the point of intersection. That is what it's asking about. So you go up to your graph and you say, oh, here's my point. Here's where the two lines cross. That's what it's asking about. It's saying, under what circumstances or conditions would the talk more, the blue one, talk more is red. Under what conditions is the red graph a better plan? What does this mean? Cheaper. Under what conditions is the talk more plan cheaper than the call a lot? Right? So you're looking at the comparison between the two graphs. So you go up and you say, okay, I want to know when the red graph is cheaper than the blue graph. Right? So you're saying, all right, cost is on the y-axis, right? Up and down. The question's asking you about under what circumstances is the cost going to be lower for the red graph. Well, the way I look at this all the time is I say, all right, pretend I'm just walking along this bottom axis here. I look up. Which graph do I hit first? The blue one. Okay, well, I keep going. Which one do I see first? The blue one. What about right here at 20? Oh, at 20, the graphs are the same price. Right? All right, that's the point of intersection, right? The point of intersection is 20 and 30. So the question, that's your decision. We call this the point of interest or the point of intersection. You're making a decision around this point as to which graph to choose, right? Well, it turns out if you have the graph, and I continue with this trend, if I go over here to like, even if it's 22 minutes, which graph do I hit first? Red. 28 minutes? Red. All of a sudden, around this point of intersection, one company becomes more beneficial than the other. And that is what is the most important thing for everything we're going to do from this point forward, is understanding what this point of intersection means and how to interpret it. Okay? So, when I go down here, I'm going to say, if you talk on the phone for more 20 minutes, choose the red graph or talk more. Okay?